Okay, so first of all, we started by measuring our breath in the Ziploc bag. And then the bag alone weighs 8.4 grams. Our first breath was 9.3 grams, 9.6 grams, and then 10.2, then 10.2. The average of all that is 9. And of that 9, 0.036 of it is carbon dioxide. Okay, for the breathing problem, we found that we take 18 breaths per minute, and 16 to 17% of that is air, and about 4% of it is carbon dioxide. So for dimensional analysis, we put 18 breaths over 1 minute, then 0.036 over 1 breath, then 52,600 minutes over 1 year.
Tree data that we collected in Prospect Park. We measured 7 trees, and tree number 1 was 106 centimeters, and tree number 2 was 298 centimeters. Tree number 3 was 155 centimeters, and tree number 4 was 257 centimeters. Tree number 5 was 102 centimeters, and tree number 6 was 219 centimeters, and tree number 7 was 209. To find out the diameter, we use the formula diameter equals circumference divided by pi. Now, they all had different types of diameters, but to find out the biomass, we calculated. We typed in tree number 1, 33.75 times log 10D equals 1.528 times 2.66 equals 4.0652 times plus negative 0.125, which is 2.815. Then we square rooted that to 10. That left us with 31268.371. I added up all the 7 trees biomasses to get 335,979.5.628. That's all the biomasses added up.
We know that Prospect Park is 7.5 acres. Also, carbon dioxide is stored by the whole park. 1 acre is about 47 meters squared. We do not know how much carbon dioxide removed from the environment by 1 acre of local forest. We don't know that. We also do not know how much square meters to acres comes to. And we also do not know the knowing of the mass of trees. How much carbon does it store?
25 times 25 equals 625 square meters. So I use 625 meters times 1 acre divided by 4047 meters squared. That equals 0.1544 acres. Then I did 1 acre times the biomass of all the trees added up in kilograms. That divided by 1.154 acre equals x divided by 1. We're trying to figure out x. So you have to do the hook by 1 acre times 335,975.628 kilograms divided by 0.15 acre. And that gives you 218,16854.73 biomass of 1 acre. You use the biomass of 1 acre number times 0.45. The 0.45 is carbon makes up about 45% of trees. And this gives you 9817584.6285 kilograms. 1,000 grams converts to 1 kilogram. 1,000 grams divided by 1 kilograms times the mass of carbon. And that ends up as 981758462.8 grams of carbon. That number you have to multiply by 44 grams of carbon dioxide. Divide that by 12.010 grams of carbon. Then do 43197372364 divided by the grams of carbon. And then you equal that, and that gives you 35965740852.2 grams of carbon dioxide. Using Mr. Wood's data that we know is overall miles per gallon is 46.868 miles over 1 gallon. Gallons of gas used is 941.955 gallons over 3 years that he used this. You divide that and you get 313.985 gallons per year. The average gas price is $2.84 over 1 gallon. Octane is C8H18, which is carbon and hydrogen. The density of octane is 703 milligrams over 1 milliliter. Unknown is the carbon dioxide over 1 year of driving. What goes into a car and what comes out of the car, you have to balance the equations of C8 and H18 plus oxygen and carbon dioxide and H2O. Then you have to do a lots emission analysis, 313.985 gallons times 3.78 liters times 1,000 milliliters times 703 milligrams, and then you multiply across and you get 8.34 times 10 to the 8th power milligrams over 1 year. You have to convert to grams of octane to moles of octane to moles of carbon dioxide to grams of carbon dioxide. Then you end up with 834,000 grams of octane per year. Then 834 grams converts to grams of carbon dioxide. The next step is to find out what grams are 1 mole of C8H18 and what grams are in 1 mole of CO2. And I found out that C8H18 has 114.2285 grams a mole. CO2 is 44.0105 grams per mole. Then we want to know grams of octane to moles of octane to moles of CO2 to grams of CO2. 834,000 grams of octane times 1 mole of octane divided by 114.2285 grams of octane times 1 mole of CO2 divided by 2 moles of octane times 44.0105 grams over 1 mole equals 527276112 divided by 228.457, and then that equals 257619.90 grams of CO2. That is the gas problem.